recall from yesterday, the second theorem was the angle subtended at the center O by an arc AB, okay, by an arc AB, or if you like, chord AB, is 2 times that subtended at the circumference in the other sector or alternate sector, right? So if you apply that to, how about the angle subtended at the center being a straight line? Okay, notice a straight line in diameter, and recall that sum of angles on a straight line is 180 degrees. So if the sum of angles, recall sum of angles on a straight line is 180, so the angle subtended at the center is 180 degrees, you know, a semicircle. That means that it is the angle subtended by that same arc AB or chord diameter AB should be half of 180. So it's 90 degrees. That's why the theorem 3 says the angle in a semicircle is always 90 degrees. Because you can see a diameter chord forms semicircles. So if 180 is the angle at the center, it must be, then the angle at the circumference APB, this angle APB must be a 90 degrees angle. So that's what theorem 3 says. All right, an example for what we just, theorem 3 that says angle in a semicircle is a right angle. Look at this question. We have to find the lettered angles. What's the value of F, G, and H? Okay, in this circle. Now to obtain angle F must be 90 degrees because you see this is a diameter. Once you see O stands for center of a circle. So the angle subtended in the angle in a semicircle, because this is a semicircle, must be half of that. So this must be 90 degrees. Okay, so if this 180, sum of angles on a straight line, remember a diameter is 180, so F must be 90 degrees. We continue now to obtain angle G. To obtain angle G is part of a triangle. You can see a triangle out. Okay, so to obtain angle G, you must know that sum of angles in a triangle is 180. Remember that from your theorem of triangles. So G plus F plus 56 must equals 180, and then you give your reason. Sum of angles in a triangle. Okay, so we know F is 90 degrees from this first part. So G plus 90 plus 56 equals 180. Collect your like term. G is equals to 180 minus 90 minus 56, and G gives us 34 degrees. Okay, that should be clear. Obtain angle H. That's the last. To obtain angle H, you have to see we have this line and this line are parallel. Okay, you can see that's the meaning of this arrowhead. Means this line is parallel to this line. So you see it forms a Z angle. Look at what we call an alternate angle is formed between angle G and this angle here. So I've drawn that. It looks a little bit smaller here. So angle G is 34. We've calculated angle G to 34. It forms an alternate angle to this angle. Now recall that this is a semicircle. Let me go up here. Semicircle. So this is a semicircle. If F is 90, then this angle here must also be 90. This angle here must also be 90. Right. So angle G. Let's come up here. Angle G is 34. So to find H is part of this lower triangle. So this is a 90 degrees, since it's the angle in a semicircle, 90 degrees. So, and this is a triangle. So H plus 34 plus 90 degrees must give you 180 degrees. So 180 degrees, you know the math, do the maths. 34 plus 90 degrees to get H. So 180 minus that's for 124. G is equals to 56. All right.